Okay, it's Miss Manili again, and I am going to show you how to solve a system of equations in three variables. So you have three equations and three variables. And this problem is a little bit more challenging than the previous one because we're going to have to transform the equations a little bit to get a variable to cancel. So in step one, it says to pick two equations and eliminate one of the variables. So again, we have to figure out the variable we want to eliminate. And in this case, you'll notice that in almost every situation, in front of every variable, there is a coefficient that is not 1. And so when that happens, it's going to be a little bit more challenging to cancel a variable. So look for a variable that has a coefficient of 1, and that's going to be the variable that you want to eliminate first. So if I notice that the only variable that has a coefficient of 1 is my x variable. And so when it comes to eliminating, that's going to be the easiest one to eliminate. So I'm going to start by combining these two equations because my goal is to eliminate x. And then in the second pair, when I get to step 2, I still want to eliminate the x. And it's going to be easier if I combine the first equation with the third equation, since again I have that coefficient of 1 in that first x. And that's going to be an easier way to cancel the x's. So let's start with the first two equations. I've got x plus 3y minus 2z, and that equals 6. And then in the other equation, I've got a negative 3x plus 2y plus 4z, and that equals 29. And so if you remember in the last situation, we didn't have to transform the equations at this point. My x's are, I think in the last problem, the y's or the z's may have canceled immediately. In this case, that doesn't happen. So because I'm aiming to cancel the x, I need to make sure that the coefficient in front of the x in the first equation is a positive 3, so it cancels with the negative 3 in the second equation. So in order to do that, I need to multiply that first equation by 3. And I got to remember when I do that, I've got to distribute that 3 to every single term. So when I rewrite this equation, it becomes a 3x, and that's going to become, so I'm distributing. Now I've got to do 3 times 3y is going to give me a 9y, and then 3 times negative 2z is going to give me a negative 6z. Don't forget you also have to multiply all the way through to the other side, and 3 times 6 is going to give me 18. Now that second equation, I don't have to transform. I've got a negative 3x plus 2y plus 4z is equal to 29. And now I want to combine the two equations in an effort to cancel the x's. So my x's are going to cancel right away, so that's nice. And then I've got a 9y plus 2y. That means I'm going to have an 11y. A negative 4z plus, I'm sorry, a negative 6z plus 4z is going to give me a negative 2z. And then I've got 18 plus 29, which is going to leave me with 47. And that's my new equation. So I've got 11y minus 2z is equal to 47. And then in step 2, again, I want to eliminate the x again. And it's going to be easier if I continue to use the equation that has the x that has a coefficient of 1. So again, I'm going to write that down. So I'm going to combine my first equation, x plus 3y minus 2z equals 6. And I want to combine that with the third equation, 5x minus 7y plus 3z. And that's equal to negative 28. And in order for my x's to cancel, the coefficient of x in the first equation has to be, this time, a negative 5. Because if it's a negative 5, that negative 5 will cancel with the positive 5. So remember, I'm going to have to change every single term in that equation by multiplying it by 5. So I'm going to distribute that negative 5. So I'm going to have a negative 5x. If I multiply through to the 3y, I'm going to have a negative 15y. If I multiply through to that negative 2z, I'm going to have a positive 10z. And then I also have to remember to multiply it through to the other side, and that's going to give me a negative 30. The second equation doesn't need to change, so I'm just going to rewrite it as 5x minus 7y plus 3z, and that's a negative 28. So now when I combine, my 5x's are going to cancel. I'm going to have a negative 15 plus a negative 7, which is going to give me a negative 22y. I'm going to have a 10z plus 3z is going to leave me with a 13z. And then I've got negative 30 plus a negative 28, which is negative 58. And that's my new equation. Negative 22y plus 13z is equal to negative 58. And so these now are, this is the new system I'm going to be working with. Now I have two equations that involve the same variables. So this brings us back to what we did earlier in the school year, and I'm going to combine these two equations. So let's write them down. I've got 11y minus 2z is equal to 47, and I've got a negative 22y plus 13z is equal to a negative 58. And so again, I need to figure out which variable I want to eliminate. If I think about my y's, nothing eliminates directly. Like I can't just add the two equations together and have one of my variables cancel. But I can see when I'm dealing with my y's that 11 goes into 22 evenly. But 2, if I look at my z variable, 2 does not go into 13 evenly. So it's going to be a little bit harder to eliminate the z because I'd need both the coefficients to be multiples of 2 and 13. But if I look at my y, if I multiply this first equation by 2, 2 times 11 is going to give me a positive 22, and that'll cancel with the negative 22. So let's go ahead and do that. I'm going to transform this equation by multiplying everything by 2. So this is going to give me a 22y. If I multiply negative 2z by 2, I'm going to get a negative 4z. And then I also have to multiply 2 times 47, which is going to give me a 94. The equation underneath does not have to change. And now I'm going to go ahead and put everything together. My 22y's are going to cancel. I've got a negative 4 plus 13z, which is going to leave me with a 9z. And then I've got 94 plus a negative 58, which is going to leave me with 36. And if I divide both sides by 9, I get that my z variable is equivalent to 4. And so now I've solved for one of my values, or one of my variables. And I'm going to do what we did before, and I'm going to substitute z equals 4 into one of these two equations. And it doesn't matter if it's the original 2 or my transformed equation. It doesn't matter. But I'm going to substitute that z equals 4 into one of those equations. I'm just going to go ahead and use the first one since it's already there. So I've got 11y minus 2, but this time I'm going to plug my z equals 4 in for z. So when I simplify, I have 11y minus 8 is equal to 47. And if I add 8 to both sides, I'm going to get that 11y is equal to 55. And if I divide both sides by 11, I'm going to get that y is equal to 5. And so now I have values for two of my variables. I'm going to now take those two values and I'm going to go back to one of my original equations. And since this time I'm solving for x, notice how in that very first equation, x has a coefficient of 1. I'm actually just going to substitute my y and z into that first equation. So x is my unknown, so it's going to say x plus 3. And again, I'm replacing my y with a number, so I'm just going to put a placeholder here using parentheses so that I don't mess up the equation when I rewrite it. So once I've got my equation down, I'm going to substitute the values for y and z into my equation. So I know that y is 5 and z is 4. And so now I can simplify. I've got x. This is going to give me plus 15. This is going to give me minus 8, and that's equal to 6. Well, 15 minus 8 is 7, so I have x plus 7 equals 6. And if I subtract 7 from both sides, I get that x is equal to negative 1. And there's my solution. And so the next step, or the last step, would be just to check to make sure that that value, or that those values satisfy all three equations. I'm not going to go through that step again simply because I did it in the last video. But the last step, obviously, would be to make sure that your solution is true. And that way you know you've done it correctly. So I hope these two videos were helpful. If you have any questions, obviously you can still come in for Bulldog Block.